Hi there, I'm Robin. You might have recently heard that Cato Networks has won the 2024 Frost & Sullivan Enabling Technology Award for SASE best practices using AI. Now, a lot of you may be unaware of how Cato is actually using AI, and even more of you might not understand AI outside of CoPilot or ChatGPT. So let's take a couple of minutes to start exploring Cato and AI. Grab your notepad and popcorn, and let's get learning. So let's start at the beginning with ML, machine learning. Machine learning is essential to how Cato Networks handles and secures massive volumes of traffic across a global network. Every day, our system processes billions of data points, forming a corpus that's used to identify and mitigate threats. Depending on the nature of the task, we apply different types of machine learning. Supervised learning for labeled insights, unsupervised learning for pattern discovery, and generative AI to create predictive threat models. In supervised learning, models are trained on labeled data, meaning each piece of information is tagged so the model understands what it's looking at. This type of learning allows us to classify specific items, like identifying legitimate files versus malware. The model's accuracy largely depends on how well the data is labeled and how comprehensive the dataset is. You've seen supervised learning in action with image classification, fraud detection, and file or malware classification. At Cato, we use it to reinforce real-time threat detection, keeping your network secure by quickly identifying known threats based on predefined labels. Supervised learning often contributes to the joy of a neural network. Now, I'm not going to bore you too much here, but effectively, we start with having a corpus. This is a nerdy name for a collection of data which we use as a basis for processing. In our example today, it's many books about dogs. Now, you know what a dog is, and so do I. But how would a computer know the difference between a cat and a dog? They both have 4 legs, hair, and they're owned as pets. So aren't they the same thing? Well, yes and no. By performing training, we can import our data and have the nodes of a neural network try to discern an answer. We say, this is a cute blank. The neurons in the network then do a whole bunch of math to come out with a judgment based on the data provided by the corpus. Once the output has been provided and the network believes there's an answer, that data is fed back into the machine to feed the collective intelligence for a better output in the future. Learn, fix, and apply. Just like how humans learn. You might be thinking, Robin, so what? Machines are smart, I know this. Well, to that, I say that this type of supervised learning is fantastic when it comes to things like DGA detection. DGA, domain generating algorithms. They're technical nasties that can rapidly spin up new vectors of attack. Now, historically, we've had to rely on domain reputation feeds to block these websites. Though by leveraging the deep learning algorithms, detection is now off the charts. AI is making life easier for hackers, so it's imperative that we use similar tools to defend against the onslaught. Hey Robin, I just saw CoPilot. I know that tool. Most folks do now, especially as Microsoft is pushing hard into integrating AI with Windows, and Apple is about to do the same with Apple Intelligence. This is something that we call generative AI, not machine learning, but generation. Generative AI uses a large corpus or database of knowledge to create new content. You might think of it as a superpowered autocorrect, predicting the next word or token based on the context provided. Large language models, or LLMs, like ChatGPT and Gemini, are examples of that technology, and it takes a whole bunch of data in before it can generate more of an output, depending on the token window. I'm not going to go too deep into generative AI right now, but we can do an entire other session about that in the future. Now, an example of Cato's use of generative AI would be the XDR storyteller. By clicking on the See Summary button in the story's workbench, the large language models are activated and the tokens start generating. This then creates a human-readable summary of all the data signals Cato has identified. It's pretty convenient, right? But Robin, everything you've shown me so far leverages supervised machine learning. What about unsupervised? Once again, gold star for your great questions. Here, models work with unlabeled data. Instead of predefined categories, the algorithm sifts through the information to find patterns and clusters. This is useful for anomaly detection, market segmentation, and discovering previously unknown connections. For example, by grouping smaller patterns, we can identify unusual network activity that might indicate a new emerging threat. helping you stay ahead of evolving risks without needing labeled data for every scenario. After all, there's a lot of vulnerability and risk out there which has yet to be actually classified. An example of this would be something like anomaly detection for tracking weird network behavior. In the image, you can see that on the 9th of February, an anomaly occurred. 389 meg of data was uploaded to the file sharing site of Mega, New Zealand. Now, on its own, this might not seem a problem. However, it was still seen as weird behavior that was anomalous to the usual traffic pattern. Cato's unsupervised models had found a cluster, a pattern, and identified that this upload does not meet the right level of pattern. So something may be afoot, and foul behavior may be present, but we won't know until we further investigate. Unsupervised models take the hassle out of monitoring large data sets, and it generally makes life easier for those who have event fatigue. So what if things are wrong? This is when we start to combine supervised and unsupervised learning to generate something beautiful for you. In this example, our unsupervised models identified traffic, something anomalous. Traffic was bad and deemed malicious. But what? Our supervised models look at the identified traffic and check the pattern against the database. We predicted that this is LatentBot, a multi-modular Trojan which has been around since 2013. Perfect. Identified, classified, and resolved, all with no human contact being needed. Wonderful. This is just but one example of our models in action. By combining Cato's use of AI and ML together, we can combine intel feeds and conduct popularity analysis to prevent cyber squatting and DGAs in line. We use custom AI models, in-house built models, as well as public and open LLMs to get the best level of visibility, assessment, judgment, and detection on the market. And bear in mind, these models run in line. That means that this protection and detection runs on every one of Cato's points of presence. But hey, that's just part of the benefit which comes from a converged infrastructure. If you want zero-day prevention for cyber squatting and DGAs in line, well, we offer this by default with our standard threat protection license. We keep our customers protected. Now remember, everything that Cato does is converged in nature. We offer a single pass cloud engine to connect, secure, and protect every one of your edges. Whether this is a branch office, headquarter, data center, or lone Welshman sat on a cold, wet isle. This architecture gives us a fantastic corpus with our data lake. This grants us a coherent set of normalized data which we can leverage to protect and secure our customers using these ML techniques. Things like anti-phishing, document classification, DLP, and more can easily be conducted with minimal interaction by our customers, all through the joy of our single pass engine. We additionally leverage more cloud-brain data for UEBA, XDR responses, and generic anomaly hunting to take advantage of how machine learning can identify, correlate, and surface potential avenues of attack. Then at the simple user level, heck, we can even use generative AIs to summarize an XDR stories, or even change the language of the Cato management application to be more inclusive of other cultures and languages. While it might seem that Cato is just a consumer of AI, you couldn't be more wrong. We have fantastic data scientists, researchers, and security experts who push the envelope of what's possible in the world of AI. We present at industry-leading conferences and write many research papers and blogs to help advance not just Cato, but the industry as a whole. Now bear in mind, this is far from exhaustive. This is but a sampler, a tidbit, an appetizer for what Cato is doing in the world of AI. If you want to know more, let me know and we can dig deeper into the future. Now until next time, I'm Robin, and thank you for listening.